Hi everybody, today let's learn about how to find the area of a triangle. So when we talk about the area of a triangle, we always think about this formula. 1/2 times the base length times the perpendicular height. Right? This is a formula that we always use to find the area of a triangle. But not every time we can use this formula. Sometimes we don't have enough information for us to use this formula. So today we are going to learn two more new methods that can help us to get the area of a triangle. Okay, before I show you how do we apply these two methods to help us get the area of a triangle, let's find the area of this right angle triangle first. Area of triangle ABC. Okay, so here I'm going to use this method, this formula, to help me to get the area of this right angle triangle. 1/2 times the base length, which is equal to 4 centimeters, times the perpendicular height, which is equal to 3 centimeters. Okay, you can just press your calculator. 6 square centimeters. Okay, so this is the area of this right angle triangle. So now let's try to use these two more methods to help us get the area of this right angle triangle. See whether we can get exactly the same answer. Okay, so if you want to use this method, same thing, we have to add 1/2 in front of this. If we use side A and B, we need to use angle C. 1/2 A times B times sine C. So if we use A and C, so this is A, this is C. Okay, we need to use angle B, AC sine B. Okay, and I forgot to type another one. So how about if we use side length for B and C? Okay, same thing, we need to add 1/2 B, C. Then we have to use the angle A, sine angle, okay, let me write again, sine angle A. Okay, now let's try to use this method to help us get the area of this right angle triangle. Do, ka, so. I hope that you still remember. Tangent is equal to opposite side divided by the adjacent side. Cosine is equal to adjacent side divided by the hypotenuse. And the sine is equal to opposite side divided by the hypotenuse. Now we are looking for sine. Okay, sine A. Sine A, if the angle is over here, this is opposite side, this is adjacent side, and this is hypotenuse. So the side which is opposite this right angle triangle, the side which is opposite the right angle will be always the hypotenuse. Okay, so S O H 4/5. Okay, so how about side B? Now the angle become okay, I write side C first, side C. Okay, so now the angle become here, so the opposite side will be here. Hypotenuse is still the same, and it will become this will become the adjacent side. SOH 3/5. Okay, so this is side B, and B is 90 degrees. So sine 90 degrees is equal to 1. Okay, now let's try to use this method to help us get the area of this right angle triangle. Area of triangle ABC. Okay, so which side we want to use? How about we try this and this first. If we use these two sides, then I need to use angle C. 1/2 times 4 centimeters times 5 centimeters times sine C. Sine C is equal to 3/5. Okay, you can try press your calculator. So simplify it, then this is divided by 2, here divided by 2. 2 times 3, you will get 6 square centimeter. Exactly the same answer. How about we try one more? Okay, now we try use another side. How about we use this side and this? If I use a side for B and C, I need to use this angle. Area of triangle ABC, 1/2 times 5 times 3. Sine angle A, which is equal to 4/5. Okay, this one you can simplify it. So divided by 2, divided by 2, 3 to 6. You get exactly the same answer. So if you want to use A and C, you will get the same answer as well. So this one you can try yourself. Okay, now let's try another method. Okay, so this formula we call it as Heron formula. So you will see S here. S is the semi-perimeters. Means that you want to take the perimeters of this triangle divided by 2. Okay, so if we use this formula, we need to find S first. Perimeters for this triangle, I think it should be no problem. Take this, just find the sum of all the side length of this triangle, which is equal to 3 plus 4 plus 5. Okay, if you don't want to write the units, it's okay. And then we have to divide it by 2 because this is semi-perimeters. Okay, so you will get 6. Okay, 6 centimeters. Okay, so if you want to use this formula, it's actually very easy. Area of triangle ABC. Okay, let's try. We should be able to get exactly the same answer as this one, which is equal to 6 square centimeters. Okay, so you open, write a square root first. Okay, how about I write 3 parentheses first? Now I have 3 sides, right? 3 parentheses. Okay, so S is the semi-perimeters of this right angle triangle, which is equal to 6. And then we need to take this semi-perimeters minus the side length for minus A, which is 6 minus 4 times 6 minus 3 times 6 minus 5. And then we have to square root this whole thing. Okay, let's check, see whether we can get this the same answer. So this is 6, and this is 2, this is 3, and this is 1. Square root it. Okay, here you will be able to get 36. Square root 36 is equal to 6. Okay, we still get the same answer. Okay, now it should be no problem to use these two methods to help us to get the area of a triangle. Now let's try few examples that we need to use this two methods to help us to get the area of a triangle. Okay, let's look at this example. The diagram shows a triangle PQR. So we have PQR. The line QR of the triangle PQR is extended. So this QR is extended, go up here to point R prime, such that PR prime is equal to PR. Okay, so when we want to sketch this triangle P, Q, and R prime, this is an ambiguous case. So if you want to draw it, So we actually, the triangle mentioned here, the triangle for part A is actually here. Okay, let me draw it for you. So from here, we extend it, go up, go out like this. Okay, I just draw it roughly. Okay, so the R prime will be over here, and the side length here is equal to side length here, which is equal to 7 centimeters. So the answer for part A is P R prime and Q, P Q R prime. So we need to draw this triangle for the teachers, and we need to show the important information. So this is 7 centimeters. And how about this angle? I hope that you remember this angle is equal to this angle, right? Because this is isosceles triangle, and this is 110. We know here will be 70 degrees. So we need to show the teachers here the angle here is actually equal to 70 degrees. Okay, now let's go to part B. So in the exam, right, you don't draw this triangle using the diagram given here. You have to redraw again the triangle. Okay, so how about B? Calculate the area of this triangle. P Q R prime means that we have to find the area of this whole triangle. Okay, so here this triangle actually consists of two triangles, right? One is over here, another one is over here. So if we can find the area of this triangle and this triangle, we just find the sum of them, then we will be able to get the area for this whole triangle. Okay, so here how do we get the area of this isosceles triangle? This is 70, here will be 70 as well. If this is 70 and this is 70, total will be 140. The sum of the interior angle of a triangle will be always equal to 180 degrees. So if we want to get this angle, R, P, and R prime, R, P, and R prime, then it will be 180 minus 70 degree minus 70 degree. So which is equal to 40 degree. Okay, let me label it first, 40 degree. Okay, now I have the angle here and the side length here. So I can get the area of this triangle easily. Area of triangle P R R prime. P R R prime, 1/2 times 7 times 7 times sine 40. Okay, this one you just press your calculator. 1/2, go. Okay, 15.75. Okay, so now let's proceed to find the area of a second triangle over here. Oh. Okay, so now I want to find the area of this triangle, right? I use this side and this side. If I use this two sides, I need to use this angle. Area of triangle PQR, 1/2 times 8.2 times 7 times sine 110, 110 degree. Okay, it will be 26.97. So now we can get the area of this triangle PQR prime. PQR prime. It will be this and this plus together 15.75 plus 26.97. So if you want to be more accurate, right, you can actually take more decimal places, and they here only round off it to 4 significant figures. Okay, so the answer is 42.72 square centimeters. Okay, let's look for try this another example. The diagram shows a triangle ABC, where AB is equal to 7.64, AC is equal to AC where's over? Okay, over here, 6.82, and the BC is equal to 12.3. We want to find the area of the triangle ABC. So this we cannot use 1/2 times the base length of the height because we don't have the height, don't have the perpendicular height, and we cannot use this formula either because we don't have the angle. So we have to use a Heron formula. Okay, so if I want to use a Heron formula, I need to find the semi-perimeter first. As 7.64 plus 6.82 plus 12.3, and then divided by 2. Okay, so you will be able let me check it. Okay, correct, 13.38. Okay, now the area of triangle ABC will be equal to, okay, so we have the S, which is equal to 13.38 times 13.38 minus 12.3, okay, for this side, then times 13.38 minus 7.64, okay, and the last one, 13.38 minus 6.82, and then don't forget we need to square root the whole thing. Okay, so you square root it, you will get 23. Okay, we can just correct our answer to 4 significant figures. It will be 23.33. Okay, so this is the area of this triangle ABC. Okay, for part B, we want to find the perpendicular distance. Perpendicular distance from the vertex A to BC, which is over here. Okay, the perpendicular distance from the vertex A to BC. So how do we get this perpendicular distance? So this is actually the perpendicular height, right? So before we learned this Heron formula, we know that we have another method with which we learned in primary school. Area of a triangle, area of this triangle will be equal to 1/2 times the base length times the height, right? Perpendicular height. And now we know the area of the triangle is equal to this 23.33. So we can just use this information we got just now, plug in over here. Okay, then we should be able to get the value of h. So just take this 12.3 divided by 2. 6.25. Okay, so 6.25. times h. So h is equal to 23.33 divided by 6.15. Okay, so I just round off my answer to 4 significant figures, then it will be 3.794 centimeters. Okay, so sorry, this one should be, let me calculate again, 23.33 divided by 6.15. 3.793, oh, should be 793. Okay, so this is a way how we use the Heron formula to help us to get the area of a triangle, and then how to find the perpendicular distance of a vertex to a side. Okay, let's try one more example. The diagram shows a parallelogram PQRS. So PQRS, this is a parallelogram. So we know that this is 7, here must be 7 as well. If this is 5, and here will be 5 as well. Here and here parallel to each other because parallelogram, and this side and this side parallel to each other. Okay, so the whole thing, the area is 32.9 square centimeters. Calculate the angle RSP. Okay, where's RSP? RSP is over here. We want to find this angle. How do we get this angle? Okay, so how about I draw a line over here. I break this parallelogram become 2 parts. Okay, so these 2 triangles actually they are congruent. This angle will be the same. Okay, let me draw 2. So this will be the same as this one, right? Alternate angle. And this angle will be the same as this one. Alternate angle. So these 2 triangles they are congruent. So we can, if I, let's say, now I just focus on this triangle because I'm going to find this angle, right? I just focus on this triangle. So can I get the area of this triangle? Yes, we can. We just take this one, 32.9 divided by 2, right? Okay, let me write over here. Area of triangle PSR is equal to 32.9 divided by 2, which is equal to 16.45 square centimeters. Okay, now how do we get the area, the angle of this RSP? We know that 1 over 2 times 7 times 5 times the sine, this angle, will be equal to the area of this triangle, which is equal to this, right? Times 7 times 5 times sine angle RSP. RSP. Will be equal to the area of this triangle, which is equal to 16.45. Okay, here just press your calculator. 12.5. You just press the calculator. 1 over 2 times 7 times 5. You will be able to get 12.5 times sine RSP. Sine angle RSP 16.45. Okay, so sine angle RSP, not RSR. Okay, so RSP 16.45 divided by 12.5. Okay. Oh, I'm sorry. Actually, I did a mistake here. Okay, now we try to press this one. Can you figure out where's my mistake? Okay, now let's try this one. 16.5, 6. Okay, let me press this one first. 16.45, then 12.5. Okay, this is actually not correct. I just want to show you where's my mistake. Okay, and press equal. then this is actually equal to 1 point something. Okay, let me check this one. 1 point something, right? So if you want to find this angle, you shift it, then you press the sign, answer. You will have some problem over here. Error. So this is actually not correct. Where's my mistake? Okay, my mistake is actually it's actually over here. 7 times 5 divided by 2, it should be 17.5. Okay, so this is not correct. 17.5. So this is 17.5. Okay. Okay, now this time should be okay. 16.45 divided by 17.5 equal. Then we want to anti-sign of this answer, right? Shift sign answer. Okay, we get this answer, but don't write this answer. This is not correct. Why? When you look at this diagram, you know that this is actually an obtuse angle, which is more than 90 degrees. This is less than 90 degrees. We know this is not the answer. We have to take the 180 minus the answer. Okay, so the correct answer should be 109.95 degree. Okay, let me check again. Okay, correct. So this is the correct answer for this question. Okay, for this video I just stop here first. See you next time. Thanks for watching. Bye bye.